Hello to everyone. I will be talking now about the hermeneutics problem, and this is the fourth one of the series Philosophy of Computer Science. This is the table of contents. First, I will refer to the Philosophy of Computer Science series, which I have been presenting during the last 3, 4, 5 months. Then I will talk briefly over the hermeneutics philosophy. Then I will talk about the hermeneutics software engineering and the competences necessary to overcome the problems, the research work, and conclusions. Here are a set of talks which I have presented and I will be presenting. Imperfect information, early decomposition and ambiguity resolution, and constructability. These 3 items I have presented already. The remaining talks today we will present the hermeneutics problem, and the other problems I will be discussing, presenting in the future. Here is a list of links related to the past 3 talks I have given. It is advisable to follow these talks as well because all these inherent problems are related. Inherent problems are the problems that cannot be solved perfectly. Nevertheless, acceptable solutions may be found in practice. Interestingly, problems are in the problem space. Inherent problems are embedded in the nature of the problem context, and as such, they are not necessarily related to solution technologies. Competences for solving inherent problems perfectly cannot exist in our physical world. So, in fact, what we try to do is we try to know what we cannot be knowing. Here is a boundary. This is an imaginary boundary. This boundary, this wall, separates 2 universes, the universe of inherent problems and an imaginary universe of non-physical competences. Progress in science brings us closer to this wall, but we can never cross this gate. Now I will be talking about the hermeneutics philosophy. Here we have the statute of the famous author Goethe. And here is his book, Faust. And this lady tries to interpret this book. Hermeneutics is the theory and methodology of interpretation. So basically, you can interpret in 2 ways, traditional way and hermeneutics way. Traditional way is shown here symbolically. She reads the book, interprets the text as it is with its own context and its references. However, in the hermeneutic interpretation, she interprets the text together with the author's intentions and all the relevant context of his environment. Somehow, she defines a model about the creative process of the author, and he is Goethe in this case. You can analyze author's context from many different perspectives. You can analyze from the perspective of childhood and family, psychology, personality, character, social class, religion, other writings, and so forth. So methods emphasize different aspects. So this process, it depends on the adopted hermeneutics method. Hermeneutics has created a considerable number of publications because of the possibility of analyzing authors' context from many different perspectives. This is a very complex process to define all these models. The one who interprets the author's context will be somehow also reflected in this interpretation, will bias this interpretation inevitably. In order to remove the bias, you have to also interpret the interpreter's context. And this will create a chain of interpreters, which makes the process, of course, very difficult. Therefore, modeling author's context must be carried out in a very objective way. To overcome this problem, the hermeneutics methods must be objective. For example, by adopting objective hermeneutics, which has evolved from interpretation of text to fundamental method of investigation for every kind of sociological research. In the end, of course, when you see a social interaction and you want to analyze it, you can describe it, and then you form the text, and then you can apply hermeneutics methods. The objective hermeneutics approach, for example, has three variants: the detailed analysis of a text at different levels, the sequential analysis of each individual contribution step by step, the full interpretation of the objective social data from all those who participated. Here is a link. For example, you can look at this link. Now let's look at the hermeneutics software engineering. Here we symbolically show a typical software development company where, customer requirements are processed systematically, and in the end, company wants to develop a software product or software system, and this will be delivered, for example, to the customer. In order to do that, of course, the members of this company carry all kinds of activities, such as specification of requirements, analysis of requirements, conceptualization of problems to be solved, searching for possible solutions, expressing the chosen solution in some design notation, and finally, mapping the design manually or automatically to programs expressed in some programming language. What is very important, maintenance of the delivered product is an also essential part of software engineering. And many people have reported that actually this is the most costly part of the software business. You may apply, of course, different methods like very strict order, or you may use agile methods and so forth. Here you see a number of different software business models. Basically, these models are complementary. So in the first one, software is sold with a service agreement. Within the guarantee period, the company guarantees to replace or repair the product if necessary. After that, possibly the customers have to pay a certain amount of money if necessary. And the second one, software is leased or rented with a service agreement, and you have to pay annually or monthly a fee to get to use the software system. And in the third one, actually what is shown here is symbolically the digital ecosystem approach, where multiple companies contribute to the digital ecosystem infrastructure, like, for example, we have in mobile phones. The software evolves continuously. The software company evolves continuously. Software engineers change companies. Technologies change continuously. And all these changes will have, of course, an impact on the company. Not only on the company, also the products that are delivered, they will be affected. So therefore, you have to manage this process, actually quite uncertain process, continuously changing. This also has an influence to the software maintenance because engineers move, for example, and you have to repair your product or extend the product you have delivered, provide a new version. All these, of course, must be carried out in an economical and successful way. When we look at that, a program running on a processor, in fact, processor interprets the programs literally. I call this a fundamentalistic interpretation. Well, the statements are executed one by one, just as they are defined. However, when software engineers do maintenance, they have to understand the program semantics to debug and maintain programs. Literal interpretation is not sufficient. Processors do literal interpretation. For example, if there is a bug, you have to understand where this bug is coming from, and possibly this bug may also come from the psychology or all kind of assumptions made by the software engineer. So there are all kinds of techniques to actually ease maintenance. For example, computer-supported documentation. For example, source code analysis. You can try to do tracing in different ways. Explicitly representing the design rationale can help actually to understand and to maintain software. Developing techniques to deal with keeping models and source code consistent with each other. This can help because you can look at the model and understand what software is doing. Adopting change impact analysis to cope with evolution of requirements, for example. Big data analytics and associated techniques with big data analytics like machine learning and such. Well, there are a lot of issues with these approaches. They are helpful, but you have to carry out these techniques and implement them in a very careful way. For example, documentation techniques can help, but unless they are made accessible to other related techniques, their usage is limited. Documentation must be actively accessible in order to reason about them and process them. Pure code analysis is limited because it's not possible to retrieve the requirements, design rationale, domain knowledge by only inspecting code and its behavior at runtime. Tracing requirements to code and testing activities are only meaningful if tracing is not limited to syntactic dependencies among entities, but also semantics of interdependencies are traced as well. Formulating design rationale can help if the formulations are expressive and if they are accessible computationally through the tracing relations. This, what I call active design rationale. Keeping models consistent can be only effective if models and interdependencies among models are specified formally, and invariance of models can be checked and enforced in practice by means of efficient algorithms. An effective change impact analysis requires formalization of models at each phase and between phases of software development. Big data analytics is useful, but requires input from all other techniques mentioned above, and such information may not be available. Of course, you can extend these techniques, for example, with machine learning techniques in order to improve the data stored in big data sets or clouds and so forth. When we analyze this process from the traditional and hermeneutics perspectives, in traditional one, she interprets the program as it is with its own context and its references to other software systems. But in the hermeneutics case, she interprets the program together with the software engineer's intentions and all the relevant context of her development. Somehow, she defines a model about the creative process of the software engineer. What we can say is that perfect understanding of a program is only possible with successful hermeneutics-based computable maintenance. But you know, this is quite complex. I mean, this book is very interesting because it's about the psychology of computer programming. And we can see actually how psychology of the software engineer can influence his or her output. Uh, of course, you may try to reduce the effect of psychology, but this is actually not a new book, but a very interesting book. So I advise you to read. Now, I would like to refer to reflective modeling and or reflective programming. Assume that this is our software system and we have defined a model for this software system. Of course, you may define all kinds of models, like you may define a model which represents the structure of the software system considered. You may define, for example, a computational model and so forth. And this, what we call, we will call a reflective model of the software system being considered. If these two are causally connected, for example, if we change the software system and the model is changed accordingly, or if we change this model and the corresponding software system changes as well accordingly, then we call these two are causally connected. This looks like actually a feedback control system. For example, here we show a feedback control system. There is a system we want to control, and we have to, of course, in order to control this system, we have to make a model of it. And then we measure parameters and we compare the measured parameters with the desired parameters. And if there is a deviation, then you try to actually correct the system. So this could be also considered like that if there is, of course, a causally connected relation between these two. This is what we call reflective modeling, reflective programming, reflective systems, and so forth. And many people refer to the PhD thesis, which is shown here, Smith's work in what is he called procedural reflection in programming. Well, hermeneutics is similar to that, but hermeneutics is, or in other words, computable hermeneutics is reflection to creation. So here we have a child, and you want to understand actually why this child behaves in some way. And in order to form a better understanding, then you also look at her parents and how parents educate their children and their behavior and so forth. So what we see here also, a child, but in order to understand child, you want to know actually how this child has grown up and what kind of family is she has. So computational hermeneutics is a fundamental step towards realizing automated software maintenance. This requires, however, gathering the hermeneutics information about a software design process right from the beginning. Now we will give some definitions of hermeneutics-based software engineering. A hermeneutics-based software engineering aims at developing software systems that integrate the decisions made by the software engineers during analysis, design, and implementation phases. In other words, hermeneutics software engineering regards software as a means for transmitting experience, views, and knowledge of software engineers to the end users, and maintenance engineers here can be considered as end users as well. In contrast to conventional methods, a hermeneutic method makes this information explicit and integrates uniformly with software. This is quite important, what we mean by integrating with software. This approach is different from adding commands or hypertext-like documentation because the information collected by a hermeneutic method becomes part of the semantics of software, but not an ad hoc information. This means the hermeneutic model, let's call it like that, and the traditional software, they have to interact with each other computationally, and they have to adjust their behavior accordingly as well. In hermeneutics approach, a software program is interpreted not only with its constituents, like, traditional processor interprets in this way, but also with the model of its creators and the creation environment. The program that is being interpreted can reason about the creators as a part of its functional behavior. To this aim, such a program continuously checks its actual behavior with respect to its design rationale of existence. Also, in some cases, of course, design rationale may also check the actual behavior of software and may adapt itself accordingly. The hermeneutics problem, however, states that it's not possible to objectively reflect upon the behavior of a software system together with the model of its creators, because inevitably the modeler also influences the models that are defined to represent the intentions of the creators. To address this problem, theoretically, an infinite chain of meta-modelers, you may call it, is required. Furthermore, it may not be possible to precisely know the intentions of the creators if they are not documented in detail. The term objective here refers to definition of models independent of the bias of modelers. There must be a way out. In the hermeneutics philosophy, challenges similar to the ones of hermeneutics-based software engineering are experienced. But this does not prevent philosophers' work on hermeneutics. If hermeneutics is the way out for software maintenance problems, no matter how difficult it is, we need to work on it. If the researchers could recognize that maintenance is a computable hermeneutics problem, then they would efficiently direct their energy accordingly. Recognize the maintenance problem as the computational hermeneutics problem. I think this is the first step. The second step is to recognize the maintenance problem as the problem of reflection to creation. Like the hermeneutics philosophy, first, objective ways of carrying out hermeneutics-based software engineering methods must be defined. This can be investigated incrementally. You don't have to solve this complex problem in one step. A computational platform must be defined to semantically integrate existing techniques together, but from the perspective of a hermeneutics method. Active representation of design rationale, functional and non-functional properties, adaptive control mechanisms, explicit representation of creation semantics, causally connected reflective models for different phases of life cycle, semantic, horizontal and vertical tracing, analysis methods integrated in each phase, automated synthesis where possible, and using big data and machine learning techniques to optimize all these processes. These are the things we need. Actually, the clue is here in these two presentations. If you reread this text and try to avoid the problems that I have absorbed with these texts and express them in a computational way, then In fact, you are realizing a computational hermeneutics method for software engineering. So what are the required competences to overcome these problems? I have defined 3 competences to overcome the problem of hermeneutics. The first one is all explicit. This means the creator's inner state, including the intentions, can be made explicit. You make it explicit. Secondly, all objective. All relevant effects of the creator's context can be determined objectively. All reflective means causally connected reflected reasoning can be carried out, one, on any artifact and on its creation process. So if you look at this picture, here we have the universe of inherent problems, and here this is our imaginary universe of non-physical competences, and here we have the competences of all explicit, all objective, and all reflective. So here we have a number of publications related to documentation, designing and documenting the behavior of software, software evolution models, and so forth. And also traceability, design rational, and so forth. So I have already made references to these publications in the previous slides. Here is the list. There is an application of hermeneutics in natural language understanding, and this is the reference for that. And we have also carried out research in hermeneutic software engineering. I must say, this is a very challenging task to implement, to carry out. I have already mentioned that. So this is a reference to hermeneutics framework and a number of publications related to representing design rational and considering software development as an agent-based activity and so forth. Well, this is interesting. For example, in model checking, in many times you have the problem of explosion of states. If you represent the design rational in a proper way, and the model checker can refer to it, can determine actually if certain states can happen in practice, and may accordingly, reduce the design space. Here is an example of an architecture of the hermeneutics framework, what we have called at the time. So assume that we have a language runtime, which I show here, but here we have a language runtime, but it is not yet fully linked. So all software components are there without having concrete links to each other. So bindings actually may change the structure of software, and we have here design heuristics expressed in fuzzy probabilistic way, and you may also add to that requirements, for example, and contextual rules. Contextual rules may adjust fuzzy probabilistic sets according to the context. And there is a language definition. Of course, this language definition is actually used in the language bindings model, and of course, in the hermeneutics design system. So what you do here is that you put your requirements, contextual rules, and use the fuzzy probabilistic heuristics, and actually bind the unbound language model. And then you go through an optimizer, and you create an optimized language runtime according to the input from design heuristics and contextual rules and requirements. This was our proposal. Now my conclusions. We have presented the following. A brief introduction to the concept of hermeneutics interpretation is given. Hermeneutics approaches have the potential to improve software maintenance. software maintenance problem can be eased through the application of hermeneutics-based software engineering methods. Instead of developing unconnected sub-solutions, we must recognize this fact and integrate all the useful techniques holistically with the help of a hermeneutics method. To implement a perfect hermeneutics-based software engineering, the following competences are required: all explicit, all objective, and all reflective. I have also presented the related work and our research. Thank you very much.
I have a question.
Yes, please. We have worked together 30 years ago in hermeneutics, I think. I remember we wrote a paper, but it was in Dutch language, but nobody understood it at that time.
Yeah, that's also maybe the question I still have, because I think the description you gave about hermeneutics and hermeneutics in software engineering is valid. It's very much related to the idea of, I think, forward engineering, although you explained that indeed for maintenance it's quite useful and quite interesting to have all this contextual hermeneutics information so that you can repair or improve your program. Is it not an idea now to start with all the software we have from that point of view, and then investigate how you can augment or enrich these programs in order that they are better maintainable?
Yes, I completely agree. So this is also what hermeneutics philosophy people are doing. So we can learn a lot from these philosophers, actually. So there are two kinds of things we can do here. One is during forward engineering, let's do it in this way. So collect the right set of information. So we need to have hermeneutic models where you collect all this information in forward engineering. And related to the software we have to actually define means to add or to try to retrieve some hermeneutic information. Because when you look at philosophers' work, for example, they do Bible studies or they do Quran studies, and they study work of Goethe's work and so on. So they have very tough things to do, you know, to extract the meaning of the creator, let's say. So indeed, we should do that. So we should agree that this must be done. So hermeneutics is here the umbrella idea. So to see the essence of the problem. During forward engineering, we have to do, and we have a lot of valuable software systems. We have to start working on them and add hermeneutics information. Maybe not easy, but we have to do that in order to maintain them better. So I agree. This is similar to what today's philosophers do when they analyze the famous texts or even religious books and so forth.
Okay.
Yeah. So I saw work, for example. You have the book of Tao, written 2,500 years ago. So what is the context of Tao and so on to interpret? So very interesting. Maybe philosophers should also work on this instead of working on maybe things we as computer scientists not find that interesting. But of course, this is a very subjective remark. Okay, thank you very much. Any other questions? So I hope the hermeneutics idea was understood, but it was very difficult for us to introduce the software community. I think with Hans, we wrote a paper in 1992 or something like that.
Yes, we did.
Yeah, nobody understood it.
No.
Yeah.
Maybe because it was late in the night that we wrote parts of it.
Yeah. But but still, you see, I'm talking about hermeneutics after 30 years. So because I realize it's necessary, we cannot avoid it. So if we confess, yeah, that was needed, then we can actually use the huge amount of work on hermeneutics philosophy as well. So especially in Germany, there are very active philosophers in objective hermeneutics to minimize the bias of the modelers.